My name is Dr. Judith Glover. I'm a Senior Lecturer in Industrial Design at RMIT University. One of my research areas is sustainable design and biomaterials such as mycelium. Circular economy is an overarching sustainability concept. It refers to creating our contemporary economies run on the churning of materials and processes. We take environmental materials, through industrial processes, we work them into things, into widgets, then we sell those, they go out into the world, and a lot of the time they end up in landfill. So circular economy is about taking that concept of making things, materials and processes, and keeping them within closed loops. So they don't end up in landfill, they circle back, and they either go into the same materials and manufacturing processes from the original product, or they're used in different ones. We've got two pieces in the show. The pieces come out of a research project we did with Sustainability Victoria that we started before COVID. The research was actually about glass fines. Glass fines are the end of the recycling process, the mountains of little piles of glass that you can't do anything with because they're all mixed up. We had the research team split up. The engineers went and did a project with people from science, and they started to develop a mycelium brick where they fed the mycelium brick agricultural waste and they fed the mycelium the glass fines. And they developed this brick and they found out that this brick had some great properties. It was fire retardant, it had some interesting acoustic properties, but we were particularly interested in its ability to be fire retardant. The brick itself doesn't look that great. Mycelium kind of looks like this, so it's not, you know, it can be beautiful, but the brick itself, it sort of looked like Weet-Bix. And so the design team started to think about how we might be able to utilise that as a building product, where we might be able to amplify those properties of being fire retardant or acoustic. One of my other research areas is in ceramics, and started to develop or create some modular building products that were made out of ceramics, and we were able to take the mycelium insert that had the glass fines and insert that in the ceramic wall. The new project that we're doing, we exhibited that project before COVID in another Melbourne Design Week show. And what we've done for the new project is we've started to crush the components of that wall up and we're feeding it back into new mycelium bricks. We're trying to test to see if we can push the concept of circularity, that we can take the materials from the existing work and that we can keep it in a loop when it's not needed and create new work out of it. Mycelium has some really interesting properties. As a new biomaterial, I mean, biomaterials have been around for eons. I mean, the first things that human made were technically biomaterials, textiles out of wool, bags out of reeds, ceramics out of dirt and mud. It was only since the Industrial Revolution that we've started to make things that are really chemically intensive and things that necessarily are toxic for the environment or can't be broken down. So mycelium is interesting because, I mean, it is a natural material. It has some interesting properties, like it's fire retardant. It's interesting acoustically. It can deaden sound. Thermally, it can, you know, it could stop heat going through a surface or going through the mycelium surface. But it also has some interesting properties about the way that it can be used in manufacturing and the way that it can bind or grow around other materials. So you can take other materials, other recycled materials, and you can actually create forms where you combine them together. The mycelium also has this great ability to be able to grow into moulds and into shapes and into spaces. And so you can actually create forms in an additive way. You're not creating a block and then you're not subtracting that block. It's actually growing into a space or a form. I think in industries, mycelium I think would be great in industries such as packaging. Being a natural material, it can do things like be fed into biodigesters or it can be biodegraded. So in terms of other building materials, it's got great properties for wall insulation, and I know there's companies that already exist in England that are creating insulation bats that have already been used. I think it's got potential for doing things like being able to replace styrofoam, which would be quite amazing. because it's got these fantastic insulation and thermal properties to it. And I think that would be a huge thing if we could replace something like styrofoam with a natural material.
Hi, my name is Dr. Tian Hun and I work here at RMIT in the School of Sciences, and I work with mycology, which is essentially mushrooms and fungi. So here at the labs we grow fungi for in different shapes and sizes for different applications, ranging from bricks to tiles to paper to leather and all sorts of biomaterial. We're focusing a lot on fire resistance and sound absorbance, which we have a lot of publications on. Well, fungi is not as well studied as other organisms like animals and bacteria. And of the almost 3.4 million fungi that we estimate, less than 144,000 have been named and classified. And even less of that has been studied in detail, including its applications and its biology. So there's a lot of mystique surrounding fungi, and we find that a lot of the materials that they are usable for haven't really been studied. So it's really interesting to look at the properties and unravel their superpowers so we can use them in our daily lives. I think the possibilities of mycelium is amazing. We've already shown that it can be fire resistant and sound absorbent, which are going to be very important factors that we're going to face going into the future, where we become more urbanized, we're actually becoming more densely populated. And these are things that will help with our mortality rates, for instance, with the fire resistance. Fires burn and they kill people. So having a natural product that can actually mitigate a lot of those risks will be an amazing step forwards for building and construction.
My name is Kyungju Chun. I have a background in industrial design. I'm a lecturer at spatial design at Monash. I'm interested in all kinds of materials, from, let's say, sunlight to algae, ceramics to E. coli, textile to air, and baking cups to digital interaction, you name it. I'm a material girl. I have been interested in biomaterials since 2013 when I was at RMIT. And back then I worked with algal biologist. And I wanted to continue working with the biomaterials, but somehow circumstances did not allow me until the COVID breakdown. And I was forced to stay at home, and my hands were getting really itchy. And I want to really make something. What can I do? Mycelium, you can order it online and you can do it at home because you've got bowls, you've got oven, everything you need. There will be multiple work at the show. First would be the phenomenal fungi work that they are designed together with students for K5 Furniture Company, the local furniture company. So they're lightings and freestanding sculpture and space dividers. And another work is called Round Rhizome Rings with John Sadar and Simon Lloyd from Swinburne. They resemble textile that can be hung in the mid-air or on the wall. Mycelium, just like any other, I guess, biomaterials, you need a lot of care during the process and also after you finish the work. The care is not just necessarily a craftsmanship, but also really listening to its own sort of tendency and an own ability and characteristics. One of my students actually described the experience of working with mycelium was like having a dog. It's fun, but very challenging and difficult. But that unpredictability, that surprise us, and then its change over time make the material more alive. Mycelium is naturally acoustically good because it's kind of porous. So it could replace maybe other acoustic things, materials and objects, but also it can replace a lot of interior furnishings such as carpets and wall tiles and curtains, because they are naturally fire resistant. You do not have to treat with harmful chemicals to be fire retardant. I would love to say mycelium is the answer and it's open and great future, but not really. Actually, mycelium is not the answer for environmental disasters that we're having. As long as we keep the same way of consuming and utilizing our environment and for the expenses of other species. So fundamental change really is critical, no matter what kind of biomaterials or crazy materials that we would use. But like other biomaterials, I would say that it offers us a great opportunity to consider how we may change things to make healthier environment in the future.
Hi, I'm Josh Riesel. I'm a designer, maker and researcher doing a master's degree in mycelium at RMIT. Coming from a background in industrial design, I really struggled with the frameworks and the materials that the industry was built on. This led me to explore a whole number of alternative materials, mycelium included. I've been working with mycelium for the last 4 years now. It's been a really cool journey, not just from a materials perspective, but exploring the whole concept of interspecies collaboration. I'm working on a number of pieces for the show. Some of these are more traditional industrial design collaborations, and others are a representation of the research that I've been doing over the last few years. Stemming from regenerative agricultural theory, I'm exploring eco-partnered production processes, and in my case, that's soil-based mycelium object production. One piece that I'm working on in particular is an exploration of taking the mycelium material production process out of the lab and bringing it back to the soil. Leveraging known soil remediation benefits of fungi, I'm exploring how soil-based molds could allow for the production of mycelium object alongside vital soil remediation effort. Working with fungi in their home may be more of a challenge than in the confines of a lab, but allowing them to actively engage in ecosystem may be vital. My production process is very simple. It's barely changed in the last 4 years. The biggest factor in producing repeatable and safe samples is to keep things sterile. My standard mixture is a main organic substrate. Currently that's shredded hemp. A nutrient addition, currently that's oat bran, water, and of course fungi. I usually use reishi spawn, which is grain that's already inoculated with mycelium. I'll start by packing my substrate into filter bags, sealing them, and then popping them into the pressure cooker. This will give me a sterile base to my material. The rest of my components arrive sterile, but if you're adding anything extra in, then sterilize that too. After wiping down my working surface and any equipment I have, I'll pop on a set of clean gloves and get mixing. Once this is all mixed, I'll grab a clean mold and pack it in. This will be sealed and left in a warm environment, about 25 degrees for reishi, for a few weeks. Once well colonized, I'll remove it from the mold and pop it into a larger container to develop an outer skin. When full grown, the sample is ready to be dried out and put to use. Mycelium isn't hard to work with per se, but it's certainly not a quick process. Everything needs to be well planned, and a small mistake can jeopardize an entire batch. You're working with a living thing, so just like you keep an eye on your plants at home, you need to do the same with mycelium. Being a living, growing process, you can have many varied outcomes. You'll notice that none of these samples look exactly the same. There's a whole world inside of here responding to external factors. There may be competing fungi leading to metabolites developing on the surface, or maybe the fungi didn't want to consume the substrate that you mixed. I think the biggest thing with mycelium-based materials, or any biomaterials really, is not to compare them with materials that you commonly know. Working with mycelium is a collaborative process. I dare to even say that working with fungi is just as peculiar as working with another human. Respectful and considered engagement will always bring you the best results.
My name's Alia Parker and I'm a critical and experimental biodesigner working with mycelium and textiles. I'm also a Scientia PhD candidate at UNSW Art and Design. I started working with mycelium in 2017 and I became really interested in possibilities of biodesign, but also how mycelium in particular and fungi kind of presented quite chaotic and unruly ways of thinking about living organisms that piqued my interest more than, say, algae or bacteria. Or bacteria seemed harder to kind of get into working with. Whereas mycelium opens up all sorts of ways of working with kind of DIY approaches to growing mushrooms. So I guess working with mycelium and mycology, there's a big kind of DIY movement that allows for low-tech ways of working with mycology, working with mycelium, that means that you don't necessarily need to have a lab. You can do all sorts of weird things in your garage and then kind of scale up or experiment with making materials. So that really appealed to me. The concept of the more than human opens up ideas of multiple worlds, multiple others, breaks down, kind of concepts around the individual or individual organisms or even the species concept. And so when we think about more than human design, it really kind of allows us to think in expanded or experimental ways that decenter the human in design approaches, to kind of consider alternative or non-human subjectivities when you're growing and working with fungi. In my case, I guess the important aspect of that, at least in my own work, is thinking about like care as a kind of a affective and ethical and practical way of working with more than human others. The things that I ultimately really love about it is that it's always producing really unexpected results and always challenging me to kind of think otherwise and to engage with time in a different way, like time that it takes to grow, time that, it takes to kind of make things happen or set things up or understand certain aspects of an organism or not. And so it sort of challenges traditional or normative practices of design, like ways of working with materiality, that is really enjoyable and surprising. What I hope for biodesign, how I would like to see a kind of biodesign future manifest is through kind of engaging with wilding, a way of like working with wild species that haven't necessarily been synthetically augmented to perform very specific functions, but kind of engage with their, digestive and metabolic desires, in terms of different materials that they might be interested in or that keep them kind of growing and changing and evolving. Working with kind of local species and working with kind of local waste streams as well. So that's kind of what I would like to see happen, to kind of use this moment where there's a lot of interest in fungi and to think about the ways in which, in human terms, they are quite unruly, they are difficult to control, they do their own thing, but they are also constantly engaging in and requiring novel and new kind of digestive stimulus. So how do we continue to work with their chaotic ways rather than necessarily trying to bring them under control and perform very specific functions for sort of biodesign futures?